I would just like to thank you for accepting your invitation and joining us, and to give this talk on artificial intelligence and various disruptive technology, how it is going to affect and how we should take it forward. I would just like to mention something about IIRF. We were officially formed as a think tank in January, on 15 January 2021. We are in the webinars. Out was the 2-day webinar on gray zone warfare, and that was attended by a number of people and researchers from various walks of life. And because gray zone warfare is one of the most important thing, and the use of disruptive technology to avoid war, at the same time subjugate countries, is being used in the gray zone. Later on, we had conducted a number of webinars, which a couple of mention. I would mention one was a talk on Pakistan, Afghanistan, and India equation, in which Afghan national settled in USA had talked to the audience. And another one was a webinar on Kerala story, which had a lot of following, and that we had the director, we had the actress in that, and the producer of that film. And we are also conducting an all India essay competition for children. So we have just started to get started getting more visibility when we published our strategic yearbook 2023. A full 1-year effort found fruit on 20th of May 2023 this year. The book was released by General M.M. Naravane, and from now onwards we are already planned for the next yearbook also. So that's a brief about Indus International Research Foundation, and we would welcome you, sir, General Anil Kapoor, to our fold, and to guide us and take us forward in our endeavor to find excellence in whatever we are doing. Thank you. Over to Raj Mehta.
Thank you, Brigadier Sandeep sir, and greetings, ladies and gentlemen. If there is one theme that is at the center of all the strategic discourses in India today, I think that is technology. The aspect that is being deliberated most is how India can become self-sufficient, or say Atmanirbhar, in technology. As far as Atmanirbharta is concerned, and especially we are talking about in the defense industry, there's no doubt a lot of anticipation is already there in the air. Prime Minister Modi's American and French visits have generated great deal of enthusiasm in India. Euphoria, positivity, and a sense of say purpose has smitten the private defense sector and the high-tech business community as well. So this Honorable Prime Minister Mr. Modi's policy of Atmanirbharta in defense production, if you see, and a slew of path-breaking announcements made after his above two historic visits, it has infused a great sense of energy into this debate. The question that nagged always among the defense analysts since independence, and that had been, can India hope to become a global power of any reckoning with borrowed technology or imported defense equipment? And the answer had always been an emphatic no. So if you see, US, Russia, and China today occupy the top slot in the global power matrix, not because they have huge defense budget, but because they have a large inventory of advanced weapon system, or because say they have a largest standing armies in the world. No, sir. they are global military powers because their defense technology and their defense equipment are their own. For their self-defense, they are not dependent on others. The technology they use to produce fifth and sixth generation weapon system are predominantly their own. Their indigenous industry produces them using their own homegrown technologies. So let's talk about India. India is numerically considered the fourth largest powerful army in the world. So does it, and so does its Air Force and Navy are considered among the top 5. But in global power metrics, we all know that numerical strength doesn't matter, and it matters least. A nation wielding full spectrum power, the one that stands on its own feet technologically, economically, demographically, and who has its manufacturing that is based on resilient supply chain and unhindered access to mineral resources, can only aspire to become a global power. Therefore, it will be very instructive to know accurately what is the level of self-sufficiency of India in defense technology at land, at sea, at air and space, and also in the digital dimension vis-a-vis the developed nations. If this gap is wide, how India is going to close that gap? What are the pitfalls of this journey? How long will it take for us to bridge this gap? And how can we develop, acquire, absorb, and finally master these futuristic technologies? What should be our reasonable strategy and reasonable expectations in this area? To discuss all these questions and many more, we have with us today former Director General of Electronic and Mechanical Engineering of Indian Army, Lieutenant General Anil Kapoor. General Kapoor has joined us for this conversation from Boston, USA. Thank you very much, sir. However, before we start our conversation with him, let me, for those who do not know him, share his brilliant professional background. So, Lieutenant General Dr. Anil Kapoor, AVSM, VSM, superannuated as Director General of Electronic and Mechanical Engineering, where he had led the entire landscape of technology management and maintenance, repair, and overall activities called the MRO of the entire Indian Army. He had also been the Director General of the Information System, where he steered the information system management, digital transformation, and net centricity of the million-strong Indian Army. He had the privilege to being the 2 UN peacekeeping assignments in Angola, 1995, and in Sudan, 2008 and 10. General Dr. Kapoor is basically a radar and missile expert and was a key member of DRDO Integrated Guided Missile Development Program. Post-retirement, he became the Director General of MIT Institute of Defense Technology, where he formulated the PhD and MTech programs in defense technology. Currently, he is a board member of the Technology Innovation Hub, governing body of IIT Tirupati, and a professor of practice in IIT Tirupati. Have been nominated as the Vice President and Chairman, National Advisory Committee, Asset Management Society, India. He is a qualified master class independent director and member of Institute of Directors and in Indian Institute of Corporate Affairs. A gold medalist in BTech and Master of Engineering program, General Dr. Kapoor is a prolific writer and an avid international speaker on MRO mosaic of Atmanirbhar Bharat, industrial automation or industrial autonomy, humanizing assets, technology sovereignty, design thinking, corporate lessons from military leadership and learning to think strategically. So as a chartered engineer, he is the recipient of the Eminent Engineers Award 2020 from the Institute of Engineers. So who can be the better person to talk about technology other than him? Welcome, General Dr. Kapoor, sir, to the IIRF platform.
Thank you. Thank you very much.
So, I will launch you straight away to my first question. So, my first question to General Kapoor is, considering India's impressive accomplishment in the field of space in terms of successes of PSLV, GSLV, satellite, Chandrayaan-3, Mars mission et al., in missile, Prithvi, Akash, IRBMs, BrahMos, in aeronautics, LCA, LHA, LCH, in shipbuilding, nuclear submarine, aircraft carrier, and and digitization, the magical Indian stack. What do you think, in your assessment, is our actual current level of technology, of technological self-sufficiency in the above areas vis-a-vis other developed nations, especially in relation to China? Sir.
Thank you. Firstly, thank you for inviting me and thank you for the introduction. I think you covered a lot of ground already in equipment and technology, which is very interesting. It makes my task that much easy or difficult. I don't know. I'll get to know as we move ahead. But that said, I think let's first take stock of the fact sheet like you just mentioned. I think we are a resurgent India today, acknowledged worldwide. And that is why we are being invited by every global nation which is in reckoning, which has got the technology and the equipment to come and share their experience with us. And that shows our intrinsic strength. But before that, let me take a step back and say that the fact sheet is that we are perhaps the only country in the world which faces a three-front war, if I may say. The first front being the western borders, we are all aware. The second is the northern borders. We are all aware that we have the northern border where our adversary there has the designs of becoming a superpower and working that way. And then we have the third front, which is our own internal front, where again, the armed forces play still a role, whether it is disaster management or it is handling insurgency, terrorism, it all. So really speaking, we are a ready test bed available to the world. You want to try any equipment, any technology, welcome to India. We will tell you how good you are, how good your equipment is. Nowhere else in the world this advantage exists. We also have a very veritable terrain, right from underwater with a huge coastline, going through deserts into high altitude area. So you name it and we have it. And therefore, I think that is one big advantage that we have as India. The second fact is that perhaps we are also the only country which has the demographic dividend. 50% of our population, which is 700 million, is employable, which is a huge number. Nowhere in the world. We are the third largest military spending nation. So we spend hell of a lot. But the good news ends a little bit here because we are also the largest importer of defense equipment. And that's where actually both the challenge and the opportunity lies. Then we are the 17th nation amongst the technologically advanced nations. And again, an opportunity to grow up exists there. Now, looking at this complete perspective, therefore, of a fact sheet, I think we are in the throes of a huge disruption post a revolution. We have already had a revolution. Now we're going to disrupt. The last decade has shown India as a new India to the world. And I think we've taken all the hats that we've got, whether it is a G20 hat, whether it is our own position in global affairs, India stands very tall. And therefore, I would like to now come to the perspectives that you asked for under three heads. I will talk the industry perspective, which is very important to know when we say how self-sufficient we are. The second is an equipment perspective, which is very important when we look at the defense. And the third is a technology perspective, which will set the stage for knowing where does the gaps lie. Let's first look at the industry perspective. Here again, a resurgent India has proved to the world and given it a three-front strategy. Atmanirbhar Bharat is the first front. Make in India with industrial corridors and defense industrial corridors abuzz is the second front. And Startup India, which is our entrepreneurial bit, is the third front. So I think all these three coming together have created a lot of reverberation worldwide. And add to this that we have given to the world a lot of technical wizards, a lot of strategic thinkers, the latest one being Ajay Banga to the World Bank. So that is the kind of India we are today. And looking at it back to industry, I think you name it and we can do it. You yourself have mentioned it all, but I'll quickly go through. When we look at the land systems, K9s, light tanks, MBT Arjun, radars of various kinds, they all form part of our inventory, quite a bit indigenous. When we look at the marine, we have the aircraft carrier, we have submarines, we have underwater capabilities that we have developed indigenously. When we look at the Air Force, we got the ALH, you talked of the LCH, the LCA, we talked of a technology demonstrator in terms of a hyperglide vehicle. We have that today. And I think as we progress now, a little more up to space and cyber, it's all hands on the deck as we speak today. So really speaking, the hands are there on the deck. The industry is ready and bubbling. You give it to them, they will do it. And like they say in technology, whatever can be precisely defined can be precisely designed and developed. And therefore, we are into that kind of a furor. But the good story here gets a little negative when we come to the equipment profile today. Armed forces the world over, and especially in our country, since we are a very active army and we've always been one, active armed forces rather, and we've always been one, has a problem. The problem is that our equipment's life spans 40 years. None of us ever keep a car beyond 10 years, but the armed forces maintain equipment for over 40 years. It's a huge, huge exercise. And earlier, the technology timelines were not as fast as they are today. So the technology is really moving very fast. So if I may put the perspective, we have the Gen X equipment, which is 60s and 70s, and we hold some of it. We have the Gen Y equipment, which is 80s, 90s, and we hold some of it, or rather most of it. Then we have the Gen Z, which is Y2K onwards till about 2010. And then we have the Gen Alpha, which is the current and future generation. So these are the four generations. And I would not like to ascribe any figures as to what percentages we have, but I would say that sizable amount of our equipment is Gen X, Gen Y, and Gen Z. That means pre-Y2K. And if that is the reality, there is therefore a need to do a lot of technology upgrade, because one of the biggest cost centers is life cycle sustenance support to all this. And the lack of reliability that they face. I mean, MiG-21 is just one example where every time a crash raises a lot of questions, because we lose human lives in addition to a lot of equipment, which is very expensive. So therefore, I think that is where one big opportunity lies, is upgrade. Now let me get to the technology perspective. Now when we look at it from a technology perspective, today technology is on the gallop. It's on the real gallop. And today, I'll just give you one example to tell you the kind of change the technology is reverberating with. We all have known an engine. Engine is something that has been the talk of even Indo-US and Indo-France deals. But let me take this as an example to drive home a very important point. You have got something called a torsion vibration sensor. This sensor takes data, could take data very unobtrusively from your flywheel. Now, I'll make it very simple to understand. Let's look at every tooth of the flywheel which passes through the torsion vibration sensor gives it at least 10 meaningful inputs about the engine. Now, if there are 100 wheels, you got 1,000 pieces of information per minute. Every minute that it rotates, those 1,000 pieces of information you get out of it. And If the RPM is just 1,000 revolutions per minute, every minute you are generating 1 million pieces of data. Every hour, 60 million. And therefore, now you can see this is the humongous amount of data that is coming, which will give you a very different sense of the condition of this equipment. Today, equipment speaks, and that's part of my research on humanizing assets. And therefore, I think there is a huge requirement of building technology into the system. We need to go in for major upgrades because we cannot really change our complete inventory as the technology changes. But we need to have a huge technology strategy to look at technology obsolescence and technology upgrades. And sometimes it is not only obsolescence upgrade equation, it is also upgrade to get a technology of capabilities or in terms of maintenance life cycle requirement. So that is the big picture that we are looking at. Let me quickly mention something in technology landscape which is very important for all of us to know. China is called the AI superpower. They are the AI superpower. They have created something called C7 ISR, command, control, communication, computer, cyber, cognition, combat, ISR. So it covers the complete spectrum. We've got Israel, which is touted as the father of quantum technology amongst many other things, and they have a quantum radar. So really speaking, when you look at a technology landscape, all this happens through a very deliberate exercise. And I'm happy that a large number of technology missions are launched in India to take so many things forward. But I think as we progress, we can talk more about it. So to summarize what I've said, all I'm saying is that the stage is set. I think when we look at self-sufficiency, we have to give us a little more time. We have to give ourselves a little more time. But when I say giving more time, direction is more important than speed. Let us not mistake speed for direction. I think what we need is velocity, which is right direction, great speed, but direction first. Let's move on.
What I could gather from your very good explanation, sir, that we are at a stage where we can aspire to be one of the top-notch technology producer, and so to say, we are in a position to now give a competition to the other developed nation. It is not that we are still in that bygone era where we had to look always here and there for our capabilities. Yet, I feel that there is a gap existing in our technology, as we have brought out above. Still, the technological lag is sufficiently wide, though we are very well off. But the world is moving very fast, and that's why you have emphasized velocity. I mean, we can catch up, but then we need to have speed. So do you think it is possible for India to bridge this gap in a reasonable time? How much time do you think it can take Indian scientific community to fill this gap? I mean, it is a very loaded question, but still we will like to know what can be the reasonable. Will it take 10 years, 20 years, 50 years, or we are in the verge of catching up technologically?
Okay. I think it's a very good challenging question to crystal gaze at the time, but at the face of it, let me say that we've got a mission 2047. 2047, which is our 100 years, is our mission. But that said, let me again dwell a little bit into maybe a concept. Conceptually, we all know that capability takes time to develop. Yes. Intention can change anytime. Now let's focus a little bit on capability and development. When we look at capability for today and tomorrow, I feel, to my mind, there are 4 basic requirements of this capability. First is precision. Second is positioning. Third is automation. Fourth is autonomy. So in capability, when we look at it from a defense perspective, I think these four capabilities cover the complete spectrum of equipment for tri-services, right from underwater to space. Now, when you look at takes time to develop, when we look at the development perspective, here we have to look at technologies, we have to look at data. I say these are the second pillar. The third pillar here is semiconductors, and the fourth is software. I'm just trying to bridge the big tickets into 4 and 4. But the new tech world order today is actually defined by 4 Ds: data, digitization, digitalization, and disruption. And it is actually the disruption which is making all the difference. The first 3 are enablers. Data is a huge enabler. I just gave you the example of engine condition monitoring. Digitalization have actually resulted into a digital transformation, and we've all seen it in India. I think we are the captains of digital transformation. The last man on the edge, who's that shopkeeper sitting on the roadside, also today has a Paytm to carry out a digital transaction. That's the power of our nation and technology. But that said, now where does the gap lie and how do we bridge the gap? Now, we've talked of the technology vertical. The technology vertical has a problem. The problem is the 80-20 rule. 80% of the efforts actually require 20% of the time. And it is the last 20% which requires 80% effort. If we were to look at our own technology perspectives, let's look at Kaveri engine by itself, which has been on for a long time. LCA, which took a long time. It is because the 80% took 20%, but the last 20% takes 80%. And that is where the devil lies in the detail. But that said, I think it will be better if we looked at it from a perspective of a global view on this. Let me pick up a couple of countries, how they did it. Let's pick up US. I mean, since we've had a recent US visit. To my understanding and research, I think after the Second World War was a major transformation in USA. What we are looking at in India today, it happened to them sometime in 40s and 50s. In 40, RAND came up, which was their public policy think tank. I mean, that was the think tank which looked at the complete continuum of dual technologies, whether it was bringing up US within or externally. Then in 1950, they came up with the Defense Production Act. The intent was again to build defense capabilities, military capabilities, industrial capabilities, and capitalize on economy. Economy was the centerpiece, the capital economy, capitalist way of thinking. And then came up DARPA after Sputnik in 1957. DARPA started taking shape, and I mean, that was again a very well thought through strategy. And DARPA came up with AI in 1950s itself. They started AI. In 1960s, they came up with internet, and I can go on. But what I'm saying is that is the landscape. And today what they are started about 100 years back. If we look at China, and if we were to read the book, The 100-Year Marathon by Michael Pillsbury, their exercise started in 1949. So what they are today is started long back. So we have to give time. The third, let's look at Israel. Israel is touted as a startup nation, and they have mastered the theory of constraints, because that's one nation which has all the constraints, but they make the world eat out of their hand when it comes to technology. And just to make it a little interesting or sound a little interesting, I'm told that when a lady becomes pregnant in Israel, she actually goes to a school she's a state subject. She's taught mathematics, she's taught science, she does Sudoku, she's given special diet so that what comes out or gets produced in that nation is actually very vibrant. It's something like what Mahabharata talked about Arjun. So they've created the Arjuns, and they are what they are today. When we look at Japan, I mean, we've always known Japan as a huge management buff in our childhood, but I think their mantra is that they're a small nation, their requirements may be less, but export is their focus, and they've come up with the 5S strategy: sort, shine, set, standardize, sustain. So they look at the whole thing through a design thinking lens. They're designed by nature. They're designed by requirement. They're designed by fault. So it's a huge learning. I think you've asked me a question, how much time it will take. I think our marathon has started. The marathon has begun. Let's look at it ourselves in maybe every 5-year time windows. I think by 2047, a lot would have got accomplished. A lot. We have the National Semiconductor Mission, we have the National Quantum Mission, and we have the National AI Mission. We have all the futuristic missions already on our plate. The requirement, therefore, is, to my mind, a good technology strategy and right man at the right place, at the right time, with the right intent for creating the right conditions. I think if we can harness this, 2047 may even get defeated earlier. We have the abilities, we have the capabilities, we have the brain, and we have the brain circulation. I don't call it brain drain, I call it brain circulation, because a lot of individuals I met in US here actually are, their heart beats for India. The heart beats for India. And I think our marathon has begun.
I wanted to ask you the next question about strategizing technology, because what happened when I was having a conversation with you prior to this program, you had used the term strategizing technology. It was a very nice sounding terminology. And though you have briefly already talked about it, so can you elaborate a little more? What did you mean by strategizing technology development in India?
Super. Very good. Good question. Let me start with a story of India, the Integrated Guided Missile Development Program. We started in 1984, 85. ITCR got slapped in 1987. I mean, it is like a baby starts crawling and it starts getting slaps for if it wants to run, you start slapping the child. So we actually came in for a huge technology denial. At the time, IGMDP was actually flowering or going to flower. We were still in the bud stage. And we had handpicked, scientists. We had late Dr. APJ Abdul Kalam, God bless his soul, a great scientist who had actually come out of the success as a project director, SLV. So the right man at the right place, with the right knowledge, with the right skills, with the right leadership, technology leadership skills. Here's a man. And IGMDP as a program talked of technology demonstrator, which was futuristic, and a couple of technologies based on ground, land-based system requirements, aerial system requirements, underwater system requirements. Now, they came up with Agni, Prithvi, Akash, Trishul, and Nag. These were the missiles. Nag was the ATGM. Trishul was the quick reaction surface-to-air missile. We had Akash, and we had Prithvi as the surface-to-surface. And that was also the time, I'm talking of 90s when I was there, we used to talk of air-launched Prithvi, ship-launched Prithvi. I mean, I'm just sharing a thought that because it was a program, everybody was aligned in the right direction. And that's why I say direction first. What I learned out of this experience was that direction is so much more important than speed. Most of the other labs were going nowhere, going very fast, but going nowhere. Here was a lab which was moving in a very well-directed effort, in a very well-directed manner. And today, as a nation, if we feel happy about our missile program, It is because we had a very formalized missile technology strategy. We knew what to do ourselves. We knew what to give it to our academia for a technology readiness level for tomorrow. We knew what to give our industry, how to prepare our industry. We knew how to prepare our R&D organizations, which could support this effort. We exactly knew what was happening. It is like a doctor when he catches your pulse, he exactly knows what is happening in your body. So when I say strategizing technology, it means that we look at the whole thing as a program approach. Now let me pick up National Mission on Quantum Technologies. If this were the mission, which is, I say, whatever has been done, let's call it 80% done in the 20% time. And if the balance 20% is to take 80%, how do we look at it? If I were to do this, I would break it into two very clear wings: the technology wing and the project wing. When I look at the technology wing, I will look at all the possible technologies, not to make it sound very technical. I'd look at qubits. We all know bits and bytes. So we look at quantum bits. We look at quantum computing as technology. We look at quantum materials, quantum molecules, quantum sensing. So these are some of the quantum technologies that need to be developed as one vertical. Some would have to be given to academia. Some would need academia industry interface because we are not ready there. And some will even need consortium with Israel and others who are actually past masters in this field. And then we have the program quantum having the project wing. And in the projects, we could look at quantum radar, quantum communication, quantum computers, quantum cyber, and I can go on. So I'm saying if this were mission, national mission with so many crores, were actually to be converted into a program with, like I said, right hands on the deck, the momentum will be huge. The direction will be set and we'll get the velocity that we need. And same is true of semiconductor and other missions, artificial intelligence. There is a huge, huge advantage between 80s and India 2023. In 80s and 90s, we were not as vibrant, as prepared. Today, we are much better off. So I think when we look at it from a technology strategy perspective, we need to define a very, very formalized technology strategy. Let's have a national technology strategy in addition to the missions. And let the strategy, and when we say strategy, it is a vision. It's not an illusion. And a vision is something that is realistic, it is smart, it is specific, it is measurable, it is achievable, it is realistic, it is time bound. And that's what program and project management is all about. So I think if we progress that way, that route, the 80-20 will get resolved in a very short time. So that is what I meant by strategizing technology. But thank you for asking this.
Yeah, thank you. You did gave a lot of sense to us how to go about dealing with technologies. I mean, and you have talked about national mission, and you have emphasized direction more than volume and velocity. So we need a very clear, and you gave a very good example of the integrated missile system where there was a clear vision and clear direction and coupled with the volume, and we did produce tremendous results. Sir, there is a very interesting anecdote because you have mentioned the integrated missile development program of India. Just yesterday or day before yesterday, I was watching one program by Lieutenant General P.R. Shankar. He also runs a similar type of think tank and gives very good talk. And I think he was with General Bhatia. I was discussing, and he mentioned this anecdote, and I want to mention it here. That it is about 1988. He was in the missile development program. He was on deputation there, and it was that time headed by Dr. Abdul Kalam as the director, and they were producing Prithvi missiles, and they were in the initial stages of configuring it, the design aspect of it, and they had visited French air show in France. And he says that Dr. Kalam was visiting from stall to stall, looking for a navigational inertial navigational system. And every place, every people he talked to, they said that no, we cannot give it, and we don't have it, or we can't share it with you. And then in one stall, there is one gentleman who was a Polish scientist. He said, please come with me. I took him away and said that why, he asked Dr. Kalam, why are you asking for this to us? He says, why not? Because I want to initial guidance system, inertial guidance system, because we are developing it. He says, see, this system, we are sourcing it from India, from a place called Hyderabad. And Dr. Kalam was completely taken aback. He says that he took a plane back and immediately put all the staff to find out who is the vendor who is supplying to abroad this system. And he found the vendor, and they found that this technology was there. And he asked the vendor, why did you not tell us that you are making it and supplying to the whole world? He said, you never asked me. So what I mean to say, sir, in the strategy...
Sir, can I interrupt, sir, with
Sir.
your permission?
Sir.
Sir, this is Colonel Jagovind. Can I interrupt for a minute, sir?
Please go ahead.
Sir, I have also been part of the IGM DP. The actual story is slightly different. I was in 2009. The INS which you are talking about, the Agni missile specifically, had an INA-3. It's called a TNA-3. And it was not based on that. What had happened was actually, we had also reversed engineered. It is the same one which is used on a Boeing aircraft, long distance.
Yeah.
So there is...
Okay.
Thank you, sir.
Thank
you, sir.
Because we have short time. Thank you for correcting.
Okay, I'll just mention one thing. You know, let us not get into very, very specifics. I'd like to keep it a little more generic.
Yeah, the idea was
because, you know, there's an open source and we should maintain our confidentiality of information.
Apologies, sir. Apologies. Apologies,
Okay.
sir.
Yeah.
Okay. Please.
The idea was that in the strategizing, there's one term that came up at the end of this conversation, is that we need to map our own indigenous technology. A lot of technology, very high-end technology, AI, and tremendous technology are available in India itself. A lot of private startup are doing. So mapping the available technology outside DRDO is one of the things. This is what I wanted to bring home. Thank you, sir. And the next question, sir, is because it is related to now India's Prime Minister visit to USA, and you know that we have got there's a huge euphoria about India about ICT agreement, and that is initiative on critical and emerging technology signed between India and USA. So allow me to bring to your notice here, sir, that a similar agreement about defense technology and trade initiative called BTTI was signed between India and USA in 2012. There was a similar euphoria in both India and USA at that time. Indians thought that top-of-the-shelf US technology will be accessible to them now onwards without any hassle. On the other hand, US companies thought they will mop up huge technology contracts and orders in millions without any competition at their own whimsical prices. Those unreasonable expectations did not materialize on either side. And I'm sure, sir, you were there in service at that time when all these things were happening. Many say DTTI failed. In the last 10 years, it produced nearly nothing. What do you think is different between ICET this time, and why do you think where ICET can succeed, where DTTI failed?
That's a very, very tricky question. I think it's a great question as well. Let me again take a step back and say that when we look at ICET, I think the government has done the job of looking at the big picture, joining the dots at the big picture level. It is not that it didn't get joined with the DTTI, but the follow-up is very, very important. How do we follow up after this? Now, when we look at the whole conundrum, there are these, and especially when we look at ISET and all technologies, we've just talked about technology strategy. I wouldn't like to revisit that, but I'll take a step further and say, when you look at technology readiness, there are 9 very well established, globally accepted, standardized levels. TRL 1 to 3, technology readiness level 1 to 3 is academia. It's basic research, looking at the future. TRL 4, 5, 6 is converting it into a prototype, which is academia industry interface. And TRL 7, 8, 9 is looking at developing it, producing it, sustaining it. So that is the complete cycle. Now, ISET is a great opportunity. I think we lost the bus in Defense Technology and Trade Initiative because of the cost. See, there are no free lunches. There's something called business intelligence, even between every 2 industries. I'm saying even between every 2 think tanks. Yours is one. There are a lot of internally kept secrets. They are fairly confidential to the owners of that think tank or that industry, and they're never spoken. Like we in the services often follow our confidential protocols. I think these protocols have to be respected. Now, DTTI had inherent in it the fact that a lot of India being a top importer, the 3rd highest military spender, will actually create the bridge, which will be a ready bridge for supply of equipment and not technology. Though the word was technology, what was shrouded was equipment. And let me get this continuum also right. See, it all starts with the capability. I want to look deep. I want to look at 1,000 kilometers deep into enemy territory. And then comes, what are the technologies? I mean, it could be space-based satellite technology, it could be ground-based, it could be aerial. So you look at the various technologies, and now you put these technologies together into an equipment. So what is being offered actually at the end is an equipment. It's not the technology. But now when we talk of ISET, there is no trade. It's technology. It's critical and emerging technologies. Now it is for us to look at the complete TRL spectrum. TRL 1, 2, 3. Can we look at creating a bridge between, I'm just saying, MIT, Cambridge, Massachusetts Institute of Technology, and IITs in various fields of technology that we need, and we identify those technologies. AI, quantum, semiconductors, big data analytics, AR, VR, meta, 5G, 6G. I'm just blockchain. I'm just naming a few. They're all buzzwords today. But are we there? Are we there in terms of products, whether software or hardware? I just talked of the 4 developmental capabilities: technology, data, semiconductor, software. So I think we need to harness all this through academia talk, a huge amount of student research. And I must tell you here, I came across something very interesting through somebody, two very important things. One, that in the US, we talked of a Defense Production Act. Actually, Google, Amazon, Facebook, you name all the top guys, and I wouldn't like to name some, have all an allegiance with DARPA. They came out of DARPA. DARPA brought them up, and they have the defense wing, which is confidential, and they have the known face, which we all know as Google, we all know as Facebook, and we all know as Amazon. So that is the spectrum of technologies that are there. If we are enamored by the technologies that we see in the CV street, you can now extrapolate what they could be doing for the defense in terms of technology. Now, when we therefore look at this kind of a continuum, we have to look at, firstly, academia. Now, recently I happened to go to MIT and I saw something called the engine. The engine is called their workhorse of tough tech. That's one place in MIT where the top of the line students, very, very hand-picked. Top of the line industry, absolutely hand-picked, come together to look at 2050, to look at 2060, to look at 2070. That is the time window. I mean, they are looking at the immediate criticalities as well, but the time window is huge because that is the time you need. And First, you should be able to perceive what will happen in 2050. It's not an easy crystal gaze, please. It's just not an easy crystal gaze. So, really speaking, when we look at ISET, let's look at TRL 1 to 3 engagements with academia to academia. We are a huge nation. We have a huge academia. And let me tell you, our academia is also huge. I've been with IITs. They are huge. Our IITs are doing a super job. But this interface is going to be creating the necessary bridge. And though it is called Initiative of Critical and Emerging Technologies, I'd like to say it should be an integration in critical and emerging technologies. I should start reading integration. I mean, today we are a 700 million youth bulge, which is a demographic dividend. We have 23 IITs. We have large number of ICERs. We have large number of triple ITs. We are NITs, all top of the line students, all top of the line institutions. Yes, we may not be figuring in the QS rankings as much as MIT does number one, but I think when we look at Kalam was not IITian, mind you. Dr. Kalam was not IITian. So we have the brains. I think what we need is brain circulation. The second thing I want to mention is about China here. Chinese send a lot of sponsored students to US and they get them back after 10 to 15 years. It's called brain circulation. They sponsor their years or whatever, and then get them back to come work whatever they learned and rebuild it in China. So therefore, I think we need to strategize with ISET. We need to look at academia, industry and academia industry here. We have to look at DARPAs together, a lot of interaction there. We have to look at industry to industry, PPP models. So I think there is a lot of homework required. But before that, the question is, what do I need? And the answer lies in learning by doing. We have to start learning by doing. IGMDP is a stark example, and I always keep quoting it because we learned by doing. Our missiles, after so much of effort, just broke into pieces the moment they were launched because the pressures were so high that the structure could not hold those pressures. The structure just collapsed. And we had Midhani and so many other industries which came up in producing these structures. And today, the advantage is that all these technologies actually create a huge euphoria in industry and actually, should I say, strengthen your tier 1, tier 2, tier 3 MSMEs, startup system. So I think we are all there. What we need is to put a very formalized structure. And I always say, with the right people, with the right strategy, right direction, a program approach. And if we did it, I think ISET is the right choice. We have actually entered into a nation which is a bouquet of technologies, and not only current, hugely futuristic. And that is where our vision also lies. So we are aligned on our vision. We are aligned at the senior leadership level. We are aligned on our geopolitical, geostrategic aims. We are aligned everywhere. What we have to do is we have to fix alignment at the technology readiness levels 1 to 9. And if we did it as a formalized structure, ISET will be a great win-win. And what we have to do is we have to be very clear that we learn by doing and not learn by buying. Yes, we should buy some numbers, reverse engineer, meet our basic immediate needs. But in the long term, it should be Indian wars with Indian equipment. That should be the end state. And if we go towards that state, ISET is a huge enabler. And we are aware that even the French visit that has happened, there's a lot of euphoria there. There's a lot of interaction with Israel and a lot of countries, South Korea, South Africa, they're all willing to co-partner with India today. And technology is a common flavor. It is the chocolate. It's the chocolate ice cream. I think we need to look at the various flavors of this chocolate. But firstly, we have to be ready within. Otherwise, we lose time, we lose sense of direction, and speed will lead us nowhere. So I would again reiterate, let's get our efforts correctly directed with the right people designing, defining the whole system, and development will happen. It is bound to happen.
Great, sir. Thank you, sir. And just want to inform you, sir, General Dushyant Singh and Admiral Murli Dharan, I can see they are in our audience, and I welcome them.
General Sani also.
General Sani is also there. I welcome him also, sir. Thank you. So we move on to our next slide, Rishi.
Sir. Sorry, sir.
Yeah. Sir, now I will make my question a little more open. My question is that recently we have concluded a great number of defense deals in technology with the USA, and those deals, the highlights of some of those deals are shown on the slide. So I will leave it open to you that you can go, and if you want to comment on any one of them, you are welcome to do so. Otherwise, we will move to the next slide. Like GHL jet engine F212. This we will discuss separately, sir, because I have kept a separate section for it. So leaving that apart, you can, if you want to make a comment in any other 4 items.
Okay, right. To my mind, transfer of technology. I'll touch upon transfer of technology. That has become a huge issue when you look at each of these technologies. Is a huge issue which I've been grappling all my life. I mean, right through from a second lieutenant till I became the DGME. This transfer of technology is a very, very tricky term. Very tricky. Everybody tells you what to do, when to do, where to do, how to do. But why to do, nobody tells you. And the whole trick lies in why. You get the processes, but you don't get to know the design. You can reverse engineer up to a point. Beyond that, you can't. And indigenization, therefore, remains a huge moving target. Huge moving target. We've been at it for over a decade now. So, really speaking, I always say it's learning by doing. Let's do it ourselves. Let's get into reverse engineering for sure. But let's put our heads together that if I were to design this capability, what would I be doing? And let me take this example of drones. Way back, as a Major General, I took up this challenge sometime in 2014 along with IIT Kanpur. And we had something called a North Tech, which happens. And during the North Tech, we did a seminar we called IITs. And IIT Kanpur showed a lot of promise. And we made a couple of very interesting unmanned systems. And some of them are in production today. But the question is, when you look at the complete spectrum from microcopters right through till hail, why have we not, over this decade or so, come to a level where we could get export oriented? Again, my short answer is, do we have a program approach? Do we have an approach of the IGM-DP? The answer is no. There are a lot of industry. They are making all sorts of drones. Somebody is importing stepper motors. Somebody is importing other motors. Somebody is importing carbon propellers. Somebody is importing autopilot. Somebody says he's done it himself. And we have all sorts of stories. But I think the answer lies in a program approach. And for each of this, I think whether it is Boeing, whether it is C295, I think the answer lies in being committed to doing it. If we are committed to doing it, the industry is ready today. I mean, we have produced ATACs. We are now into export of equipment, all done indigenously. The advanced towed guns is a huge example. LCA is a huge example. BrahMos is a huge example. And I think this technology deal, we should look at whatever we need immediately. For sure, we cannot discount that. But beyond that, we should look beyond the obvious. That is obvious. I need 100 pieces. That's obvious. Let me take 100. But what beyond 100? I think I need to set my targets. I need to put my program in place. I need to put the right people in place. And I need to move on to create the next disruption in that field. Myself. Burn my fingers. All my fingers must get burnt. Prithvis, Agnis, Akashas, Trishuls, Nags did not happen without failures. In fact, I would like to quote Dr. Kalam and give this very important anecdote which sits in my, should I say, complete zehn जिसे कहते हैं zehn में मेरे है, is we were in the launch control center, just a pre-user trial flight, so all of us can realize the importance of this flight. First time a user trial of a major defense equipment was to happen, and the missile failed. It failed 400 meters, and everybody was flabbergasted. There was media, there was Raksha Mantri, there were the three chiefs, and there was the who's who. And Dr. Kalam just said, relax. And he went in front of the media and he says, today, Prithvi is a success. I'm surprised how can missiles be success one after another without adequate R&D. We've been doing a lot of R&D, but the deep R&D, the tough tech, is what we will do now. It's an opportunity, so it's a success. It'll give me so many lessons which success doesn't give me. And he said, failure gives you lessons, success does not. Success gives you claps and pats, but the real lessons come from failure. And post that, we were part of the post-flight analysis board, and I can tell you, hand-picked guys were there looking at the systems, and the amount of wealth of information that came out, because those were not the real data days the way they are today, but a lot of data did exist, and it took us months. But today, the reality of the whole program speaks that one failure transformed everything. So when we look at these defense deals and future technologies, we must look at failures as part of success. In fact, failure is the rhythm. Success is the end state. The journey is failures. And if we are prepared for that journey, we should fasten our seatbelts. I mean, look at our own ISRO programs. They failed a number of times. It's okay. That's the price you have to pay for being a technology superior nation, and we must be prepared to pay it. Now, let's look at the third bullet, which is our naval ships coming for repairs. I mean, it's a huge opportunity to L&T. And the Indian industry today is known globally. L&T, Tatas, Mahindras, Bharat Forges, Adanis, they're all known globally now. With a good name, with a good reputation, with a good track record. And that is very important, both in terms of quality and time. So I think we have the bits and pieces, and this is a great opportunity. I would like to talk about it, maybe in the next one, about life cycle sustenance support. If you buy an equipment at X dollars or X rupees, the life cycle cost over 40 to 50 years is 4X. Let's not forget it. I was just going through a report recently. The Government Accounting Office of US has said that last year, their expenditure just on maintenance of equipment was $90 billion. 90 billion US dollars. It's a huge amount. And they've realized the need to outsource this so that, especially since they are all out of area contingencies, they don't have to fall back within the nation. They have to have forward sustainment basis in different countries with different companies. It may be a cost-effective option. So really speaking, the flavor lies in life cycle management of equipment, life cycle management of technology. And I think these deals have to be looked at in two perspectives. The immediate needs, which is the impulse function, please do it. And the long-term needs, which has to be my war, my equipment. That should be the call. Thank you.
Yeah, great, sir. That we should not look at this U.S. Navy ship repair MRO system and Boeing C-17 logistics support as merely as a logistic agreement. For India, it is a huge opportunity of learning and getting integrated with these technologies. Next slide, Rishi. Now, sir, will you like to pick up any of these items like US semiconductor facilities and training? That it is a very huge thing for India, that this is being set up, Micron, Advanced Material and LAM. Then India joins Critical Mineral Security Partnership. This is the rare earth thing. Will you like to comment on the?
Right. Now, again, I am aware of almost all of these programs that you're talking about. I've been reading about them some way or the other. The flavor or the basic flavor remains the same. Let's look at semiconductor today. I mean, there is a huge partnership happening at the academia level. A large number of postgraduate programs, dual degree programs are starting. I mean, we have Indian universities who are associated or affiliated with US universities. So you do 9 months in India, you do 3 months in US. You do 6 months in India, you do 6 months in US. And it's not only with US. I mean, there are with large number of other countries as well in semiconductors. So a lot of, at the grassroots level, a lot of these engagements happen. At the industry level, I mean, there's a lot coming in media, especially in Gujarat, that a lot of semiconductor industry is coming. But I would say that in semiconductors, I think we have it all what we need. Yes, it'll never be enough and technology will keep upgrading. But our problem lies at the gallium level. The gallium-based semiconductors is where we need more foundries. Because that is where the whole crux lies. The second thing we have to focus on is miniaturization. Nanotechnologies is very important. Nanomaterials, nano-energizers, because everything is getting into form, fit, and function. When we look at the 3 Fs, that is where the problem lies. Everything is good at macro level, but when you look at form, fit, and function, all these things take a lot of time. So if you were to ask me about anything, I think I would, but my answer would be common, because this is where the future lies. We have to look at the whole TRL levels. We have to look at where does the academia focus, where does the academia industry focus together, and where does the focus of industry lie. And transfer of technology is definitely a good vehicle. But like I said, you will get the transfer of technology of the obvious. Beyond the obvious, learn by doing. Learn by failing, and then only would you succeed. This is the technology mantra. Now, having said this, I'd like to highlight one more issue which may not be really totally related with this, that when we say beyond the obvious, as a nation, we were the first ones to start with corporate social responsibility, CSR. And we have a full company act, which is looking at CSR, 2013 company act, which talks of 2% being recycled towards corporate social responsibility. I think time has come. All this will require huge funding. The problem lies in funding. The government programs have talked of a fund, but I think we need to create something akin to CSR. I called it corporate professional responsibility. I say CPR. Let's pitch in another 2% CPR, maybe some 10,000 crores a year or whatever it comes. I think it will create all the difference. Today, in institutions, since I'm in IIT, sometimes funds is a constraint. I'm not saying every time. Sometimes funds is a constraint. And especially for things which are very futuristic, where failure is imminent. Nobody likes to put his hands. Why? Because they know that this money is a sunk cost. But unless you plan sunk costs, you will not achieve anything. I mean, we talked of the IMDP example. You quoted an anecdote. I'm aware of some, but I remember a lot of sunk costs. And it was all accepted because that is where research will take you. It will take you into failures for sure. And you'll have to evolve and re-evolve, transform and retransform into success. So that is the journey. So in each of these, this is what I'd like to say. I think they are huge partnerships. And I think as time progresses, we'll find many more players jumping in to look at India, because I think we are getting back to our Sone ki Chidiya days. I think we are. We are the only ones who have the kind of bandwidth that is globally required, right from academia at the low end to borders where you can do trial of any possible technology and equipment. The complete fabric is available in India. So I think we are a very important partner to everybody, as much as they are to us.
Thank you very much, sir. We are actually now running short of time. We still have time. So what I will do, sir, I will ask you some short questions. Expect short answers so that we can cover all our. Rishi, go back to the previous slide. Something interesting I found in this slide, sir. It says India's JSW to produce steel in Ohio and offshore wind turbine. And then it again say India VSK to do solar panel manufacturing in Colorado. And now these two things are very, very intriguing. I mean, the Indian industry is going to USA, setting up their the establishment there and start producing there. What do you make out of this, sir? I mean, it's very interesting.
Okay, now let me say, there are two terms, build to print and build to specification. Now, sometimes the OEMs are giving you the specification and they're telling you, please print it for us. India is turning into a manufacturing hub. The whole world knows it. It is an open secret, if I may say. And therefore, we are the country which actually has both the technology and the manpower for it. We have the startup ecosystem. And what we don't have, this is where the bridges get established. This is where the handshake happens. So they give you the design and then they monitor you that you will do only for us. This is not the only one. I know large number of companies throughout India, including Noida, where I stay, where they are monitored 24/7, 365 to what do they produce. And they are only supposed to ship it to them and not make a single piece extra. Anything that is wasted has to be accounted for. So those are the kind of controls. I've seen some in Hyderabad as well. So what I'm saying is, it's not happening for the first time. It's been happening. It will continue to happen. Why? Because we have both the abilities, capabilities, and capacities. The problem lies when you look at build to or creating your own designs and creating your own specifications. That is where the problem lies. Because that is where failure will come. That is where somebody has to agree to pay for. Then only would you come out of it. So I think what you mentioned here, whether it is solar panel, renewable energy is a huge, huge sector in India. And it is not only solar and wind. There's a lot of biomass, which is creating have global impact when it comes to renewable energies. I mean, you're today looking at a large sector which is beyond wind. I mean, just when you look at EV, India is perhaps the master of EV technologies. These are industries actually surviving abilities, a lot of EV stuff. So really speaking, these have been realities, but they were not known. Today, it is, so it was overt, it is over, it's known, it is being announced.
So, General, sorry, sir.
Which is good. Sorry, just allow me to finish. But I think what we have to, like I say, look at it beyond the obvious. There's a lot of technology here which we don't have. I mean, if you were to look at solar systems, just cleaning the solar panel farm of 8 megawatt or 100 megawatt is a huge, huge exercise. The technology exists here. We need to look at that technology. It is not manual, it is automated. We have to look at the percentage of signal to noise ratio of a solar cell. The solar cell efficiency is very, very important. I mean, today it hinges around 8 to 10% when we look at indigenous. Globally, it is about, some of these companies even make 18 to 20%. But to harness full power, a lot more R&D has to go in, which is going in. So really speaking, what I'm saying is that there is a lot of backdoor work which has to go on. A lot of research has to go on in this. If you have to look at the next 40, 50 years, today is one story, tomorrow will be a very, very different story. Let me tell you, very different. And that's what we have to look at.
Sir, General Arun Sani is in the audience and he has been raising his hand, sir. Sani, sir, are you there? And would you like to ask any question to the General Dr.
Good evening, everyone. Anil, great to hear you. As always, a pleasure.
What a pleasure, sir. What a pleasure.
And to see all my colleagues in the IIRF as well. I just wanted to just flag two issues. When you talked about this issue on India's VSK to do solar panel and GSW, I just wanted to share that till about, say, beginning of last year or even just at the end of COVID, a large number of American companies who were in the medium and say medium industry space, or I would also say not really the MSME, but medium industries, looked at options and selling their were going through a bad period, and there's been a large number of acquisitions. Oblique, I would say some of the big corporate houses have been approached to come and take on assets there and to sort of bail them out when they were in a critical stage. So there is, I think, already a move of some of these people having invested in these companies, and that's how, as they're looking at, as you're aware, in the aircraft industry, all hot parts were only produced either in Western Europe or in America. So they actually approached some of the bigger companies, and I'm aware that Tata was approached both by Boeing and Airbus to take over one of their hot part manufacturing plants, because the company which they had outsourced it to, or their shareholding in which they had a shareholding, were going through a terrible period of time. So I think when you talked about these two issues, I think there has been already some kind of, I would say, input by the Indian corporates into the manufacturing sector in plants in the mainland USA itself, like we had moved into UK and all. So I have a feeling this is what it was. So I just wanted to flag that, because when you said, Anil, what these are, I find that there's been a large amount of input, because I'm aware that Tata's was offered. So that was just one issue that I wanted to flag. And of course, the rest, I mean, there's such a wide canvas. I think we'll go ahead with yours. I just wanted to flag this issue because I'm aware that Tata's was approached. We are still doing due diligence to pick up one of those plants. Thanks.
Thank you,
Thank
sir.
you. Thanks.
Thank you very much, sir.
Thanks. Thanks. Over back to you.
Yeah. Today, a lot of Indians in America, a lot of them today are actually, whatever they were doing earlier, today they are creating I always call it bridges between India and US through companies. And there's a huge amount of what we talk technology of transfer, but there's a huge amount of business reverberation Americans want in India. I'll give you a very simple example. There's a product called V-Grill. It's a vertical grill. It's a tabletop grill, which was manufactured in China and supplied globally by an American company. And the number of pieces were actually almost close to 1 lakh a year they were making. Now, over a period of time, their IPR was robbed, everything got robbed, and now they're looking at India, and they are offering this product to India in a very big way. And this is just one of the many examples where they want everything to happen in India. Today, because the kind of low-cost options they have in India, the kind of ease of doing business that is happening, and the kind of reverberation that exists globally about India, I think these are but an offshoot of that. And what General Sani mentioned, that is another way of offloading some. But more importantly, I think we have to look at it very, very realistically. All these deals have to be looked at very, very realistically. They have to be looked at in the space beyond the obvious. Something is obvious and something is beyond the obvious. And when we talk of technology, it's the results lie in failures beyond the obvious. So more failure that you achieve, the more successes will come in the future through a very well-directed effort. So that is what I want to say about all of this. Yeah, back to you.
Yeah, thank you, sir. Now I will not ask any more questions from my side, sir, because we are short of time and there are some questions in the chat box, and we will take some questions from the audience so that we can wind it up in time. I have one question from General Dushyant Singh, so I will start with him. General Dushyant Singh. Policies are in place. Startup lads are eager. They want to process of development has to change. They want collaboration at user level, not at army headquarter level, but at core and division level. Your comments, please.
Brilliant. I think he's just, let me take an example. Sometime back in Northern Command, we were making, one Israeli company came and showed us sniper detection system. And we looked at it. There were IITs there. There was DRDO there in that NOTTECH. We got them. We showed them what we did. And we created a small group at the level of what General Dushyant has just mentioned. And within 2 years of my tenure there, we produced the prototype. And within a year after that, we had a marketable product called optical target locator. So what he said is brilliant. Actually, today, we need to look at a huge user. And when I say user, the hard user. Government support, of course, will be required. Academia, industry will be required. I mean, all this did not happen without a very close, should I say, round table discussions, which would happen almost on a weekly basis between the user, between the academia, between the R&D agency and the industry partner. All of them have to be sitting down together to look at the whole thing, and then it happens. So, but what we are discussing is a little beyond this, that when we talk of, this is when we talk of TRL level, maybe 7 to 9. But when we talk of TRL 1 to 6, where a huge challenge lies into the future, I think what we need to have is a single plan. Today, Air Force has their own, Army has their own, Navy has their own, IDS prepares, puts them together, and we have a huge capability development map. DRDO has their own. So at any point in time, you've got 4, 5 to grapple with. They all put it online. But then where does the priority lie? So I think we need to have a unity at the strategic level. That means one thought of what are the top 8 or top 10 we will progress. And then the TRL 6 to 9 can happen at the user level. TRL 1 to 6 must happen at a little senior level, along with user also for sure thrown in. So that would be the model I would suggest that we should embrace. But what is his point is absolutely brilliant. It creates results. For sure, it creates results. And optical target locator and laser fences are one example which happened very fast.
Thank you, sir. I have more questions, sir, but I will take now only 3 questions I pick up, sir. One question is coming from Brigadier Sandeep Kumar, our president, and it says that need to open out with industry at the user level. MSMEs and startups as of now doesn't know what are the specific needs, though it has been announced by government that Atmanirbharta is the mantra. So actually, they don't know what the defense wants, and they are ready to buzzing and bobbing.
You know, I feel I totally firstly agree with the point. We need to have something called a user advisory group. You name an equipment, you name a technology, let's have the user advisory group embedded with the industry. I mean, wherever we are embedded with the industry, we've seen these stellar changes that I've made. Look at ATAGs. We had a user team, we had ARDE and Bharat Forge and Tata's embedded for over a decade now. And the results are there to see. So there is no doubt that firstly, you do need a user, but more importantly, you need a user with a very clear mandate, a clear understanding. You can't keep changing your goalposts. The moment you keep changing your goalposts, that is where the whole problem starts. So I think a user who's well informed, who knows what he needs, and who also accounts for the kind of timelines. You can't say I wanted it in yesterday mode and we start moving towards tomorrow mode, and then when tomorrow happens, you keep changing your QRs, and that is where the problem actually lies. I saw this even when I was in DRDL, but the good thing was they stuck on to whatever was their mandate. They did not, they said, okay, this we'll do in mod 2. So I think how we need to progress it, we look at mod 1, mod 2, mod 3, mod 4, just like in ALH, we have Mark 1, Mark 2, Mark 3, Mark 4. And in most equipments globally, with every technology upgrade, you upgrade some features that may be required. So there'll be some low-hanging fruits which can immediately come. There'll be something which will need some time. And as the technology keeps getting matured, you can keep infusing it. So I think that is the kind of journey. So we need to revamp our thinking. In the core of EME, which I headed, we had something called maintainability advisory groups. They were playing a very big role in this interface. I think they need to be reinvigorated, thoroughly reinvigorated. Unfortunately, quite a bit has been cut off because of lean thinking. But I think lean thinking is required, but at the right place for the right project with the right composition we need to build this as advisory groups. It will create the difference for sure.
So, the another question is coming from Group Captain Asutosh Kumar. Sir, you very appropriately mentioned about DARPA and its contribution to the technology build-up. Today we have AI, internet, and many other things thanks to DARPA. Traditionally, the flow of technology used to happen from military to civil and commercial world. The flow has reversed in a way to a large extent. The closest equivalent of DARPA is DRDO, an associated organization in our case. What specific steps do you think could be appropriate to bring DRDO?
Yeah, I think this has been a question that has always been asked. Now, you see, you've got a very huge organization against a very lean organization. DARPA is not, they're just one organization, which is about 500 odd people, which have huge amount of interface with industry. And they have a think tank of RAND. So if you see, actually, it's quite a good continuum. There's policy, and there is ideation, there is problem statement defined, and there's a solution coming. So, and there is the empathy session happening with the user. So really speaking, it's a very well evolved organization with a particular intent. Now, we need to, there's been a large number of studies on DRDO as well to make it lean. And I would say that for sure it needs a relook. We need to get every lab program or project oriented. There is no doubt in my mind. I mean, if we have DMRL, they should be having a couple of projects that they are, and like I said, a project and a technology linkage. So there are two paths they'll have to redefine for themselves: a technology path and a project path. Just like in IGMDP, we had a propulsion system group, and they were looking at all the possible types of propulsion system. We had the guidance group, which are looking at all guidance control relationships, and we have the project groups, which are Prithvi, which actually absorb these technologies, absorb these systems, and if there was a failure, it was shared. So I think we need to look at a formalized technology strategy in DRDO, get the labs realigned. We've done it in ordnance factories, corporatization. I'm not talking about corporatization. All I'm saying is, let's look at a disruption there. We have to disrupt this. We have to, there is DRDO industry interface. All this is happening. For sure it is happening, and I'm aware of it. But I think if we have to model DARPA, and if we have to look at the future, for sure we need to get lean. But more importantly, we need to get direction oriented. And if we have to get direction oriented, we have to look at a technology approach and a project approach through programs. So if we are looking at quantum, let's look at a couple of projects, couple of technologies, and some labs with handpicked people doing this job. Others, maybe we could look at the way we looked at OFB over a period of time, either give them retrain them for the needs, or give them voluntary retirement for getting into industry and other places where they can definitely do a good job. So this kind of a rethink has to be firstly accepted. This change has to be accepted and then implemented. Both the things are required. But definitely DRDO is, should I say, majorly reforming itself. There are huge changes that are happening. Are they enough? I'm not too sure. Are they well directed? I'm not too sure, because I don't have all the relevant information for it. But I am for sure convinced that if IGMDP was successful, it was because it was a program involving a number of labs, but with a number of projects, with a number of systems. And I think it was bringing everybody together. It was one thing, that it was the hub and spoke. IGMDP was the hub, and the labs were the spoke, which were feeding in with a very, very well-directed effort. I think if we get into that mode, we have a large number of programs. I think with all this, the horse will be in front of the cart. And I must tell you one more thing, because I know it is short of time. Those in IGMDP, they have a system that if you get 3 outstanding, and if and then you are put through a promotion board. If you have 3 consecutive outstanding, or moment it becomes 3. And in IGMDP, most of these guys got 3 consecutive, then they appeared in a board, and in 10 to 12 years, they became equivalent to brigadiers. So, but the fact is, they were worth their weight in gold. Some of them were lightweight, but some were heavy, but they were worth their weight, because Intellectually and cerebrally, they were there. So I think we need to follow, it's a 360-degree thing that we have to look at: projects, HR, retraining, and of course, enhancing technical thresholds is a need even for them. I may be a scientist, like I'm an engineer of 1985 vintage. I'm outdated if I don't keep myself current every year. So we have to look at these things. How do they keep themselves current? Because when you're looking at technology, you cannot be sitting, patting your back on past. You have to look at the future and keep rolling your sleeves up. That's the approach. Not the pat approach, but the sleeve approach.
So there are two more person in the audience, Admiral Muralidharan, and another is Mr. Subburaju. Muralidharan, sir, I am sorry to disappoint you that we did not discuss much of Navy and naval technology because of our shortage of time, and you see the scope is over, but we will definitely come back something specific on the Navy, because Navy, a lot of things are happening, and we will like to have more people like you also to contribute in that discussion. And Mr. Subburaju is from Infosys. He is now no longer in the Infosys, but he held very high position in the Infosys, and he is one of our founding members in the IIRF USA, but based in Bangalore. And he will definitely like to listen more about digital technology and software, and there's so much AI and so many things are happening. So sorry, Mr. Subburaju, we will have something very specific to you also organized. Can you take one question, sir? We will expect a short answer to you because we will close it after that. And this is from Mr. Jay Govin. And he says, sir, I am presently in academia, being in IGMTP and EW DRDO projects. So he is man from the field. My worry is we are very slow. Countries like Iran and Turkey are exporting armed drones. We are still in development and testing phase. Similarly, in many other fields, we are surely developing, but very slowly. As an example, gap with China is actually increasing day by day. In every field, sir, how do we need to focus on implementation with clear timelines like it has now been done in National Quantum Mission? I think you covered this point, sir, very broadly in your initial talk, but you can still give a short answer to the query.
Okay, what I have said is that let's look at drones or unmanned autonomous systems as a program. Do we have a program called unmanned autonomous system? The answer is no.
No.
And when we look at this space, I said right from micro to hail, we have the complete continuum, and the technology stack is huge. I mean, today you got these, and it's moving around in WhatsApp. You have a bumblebee. It can come, or a fly, it can come and sit on your window and listen to every possible discussion and relate. That is the technology. You can arm it, it will hit your person in the head.
One single bullet.
So really speaking, I think it requires a program approach. Very simple. One-liner. Let's have a program approach. We'll put the horse in front of the cart. We'll move fast. I totally agree with you. Turkey, people, the whole world is looking at TB2. And Iran, people looked at Houthis using it way back. It flew 500 kilometers into Aramco. It's supplied to Russia. So I mean, if these countries can do it, why can't we? Your question is brilliant. I am also of your view. In fact, I would like to say that we need to look at program approach sooner than later. It will fix a lot of ailing problems. A lot of these gaps that we look at, technology gaps, all these gaps will start getting filled. And IGMDP is one good example I have already stated. Yeah.
Thank you very much, sir. So that will bring us to the end of our program. It is already 9 o'clock and we started at 7:30, so 1.5 hours. Brigadier Sandeep, sir, will you like to give some closing remarks, or you will?
Allow me one last minute. Allow me one last minute.
Sure, sir.
I have been a strong proponent of technology sovereignty. In fact, I say we have a Constitution of India. If I were to make a Constitution of India on technology perspective, 1947, and I make it today, I would say we, the people of India, having solemnly resolved to constitute India into a technology sovereign global power.
Lovely, sir. Fantastic. Yes, sir.
And if we did that, I think we will start moving like nobody else has moved. We will become the case study on how we transformed. And unless we look at the big picture and the small picture in a cogent manner, it is not one-off. It has to be a full kind of a well-directed effort. Grassroots top, bottom up, top down. There is a huge amount of reverberation. There's a huge amount of capability. Are we harnessing it? It is like the brain. It controls everything. The whole human body is controlled. All every asset is humanized by this brain. I think we need to do that. If we did it, we will make all the difference. And since we are running out of time, I would not like to say, but I'd just like to say that we need to have a national technology strategy. Let the National Technology Day, 11th May, become the day like we have our broadcasts on our budget on 28th February. Let there be a technology forecast as to what we have achieved and what we will achieve on 11th May. Let it become the National Technology Broadcast Day. With that,
brilliant, sir.
Thank you very much.
Very well, very much needed, sir. Very much needed. I think your idea of seeking a constitutional amendment and putting it in the preamble is a brilliant idea, sir. I mean, howsoever, I don't know whether it can be done or not, but it is brilliant. So, Brigadier Sandeep, sir,
Thank you very much, General Dr. Kapoor. It has been a very nice and eye-opening delivery of your ideas and how it should be taken forward. So actually, technology is going to take over our day-to-day life, and so much so in warfare also, and also in survival. There is a need to get out of our habit of keeping. As armed forces, the keeping had a habit of keeping ourselves and not getting involved in certain developments which is going to take place. Since this, we'll have to do it because it is going to take over our day-to-day life as well as our survivability and use in the warfare. And we have to get out of that, and we have to. From the lowest level, at the user level onwards, we have to be updated. People have to be trained. It is not that you just do dhawa and things like that or fire an artillery from there. The warfare is going to change tremendously. So it has to go down to the grassroots level, and they themselves has to identify, because these are the people who are going to fight war. If you remember, the Gurkha told for command, for a CO, this is my LMG position. The commander, he told the commander, this is my LMG position. And for the GOC, it's a different LMG position. And finally, he will fight from that. So these are the people who is going to make difference. So that is how the technology should, come down to the lowest level and reduce the gap to get these things employed in warfare as such. It is going to be same as far as a normal life, day-to-day things are concerned. And that's what you had put across, to have a program policy. So we are very thankful to you, sir, and all the audience for giving us a chance to listen to you, sir. And we will continue with this on specific subjects, and I'm sure you will accept our invitation to give us more talks on technology and how it is evolving and how it will be in our daily life as well as in warfare in the future. Thank you very much, sir.
Thank you very much, Brigadier Sandeep and IIRF, for giving me this opportunity, and thank you to the audience. It was very nice, to ideate along with you. We are into a huge amount of ideation. We have to be into that, but more importantly, we have to move through a very, very well-directed effort. I mean, the past may not be very good, but the future is for sure. And embrace failure. Let's move in the direction to embrace failure. Success will happen for sure.
Absolutely. Failure makes you succeed.
Yeah.
That's it.
Thank you.
Thank you, sir.
Thanks a lot.
You do, sir.